All right, I'm going to go through this study guide for Unit 1. I kind of simplified things because this is going to be your first test or quiz. And there are three kind of sections to this. One is going to be defining key terms. The other is drawing the models that we learned about of the atom. And then lastly, I have some key concepts and questions that I want you to be able to do. So I'm going to start by just really quickly defining these key terms. Now, where I'm getting these definitions is from those PowerPoint slides that we went through together over the course of a couple of days. So I already wrote this out. Matter is the stuff that makes up physical objects in the universe. So all physical things are made of matter. Now, this is kind of a vague definition, and we're going to be a little bit more specific as we continue the course. Now, matter has two key components. Matter has mass and matter has volume. Mass is the amount of matter in an object. And we measure mass using grams. So if we say that the mass of an object is 5 grams, that's describing how much matter is in that object. We would say 5 grams of matter. Matter also has volume. This is the amount of space an object occupies. So how much space does something take up? And we measure this in liters or milliliters. Usually I'm going to use milliliters in here. Another thing that you might see if you Google it is centimeters cubed. 1 milliliter is 1 centimeter cubed. Now, something that relates mass and volume is density. So density is the ratio of mass and volume for a substance. And so we had an equation to describe that, and it was density equals mass divided by volume. So that's a ratio right there, mass over volume. Now, as we kept going, we said that all matter is made of atoms. And atoms are the basic building block of matter. And we said that it's the smallest unit of matter that has chemical properties of an element. Now, different types of atoms are labeled as different elements, and this is where we get into the periodic table of the elements. So elements cannot be broken down. They cannot be chemically broken down into a simpler substance. So for us, we were saying elements are just the different types of atoms. If you change the atomic nature, you change the element. And so it's no longer that element. So it cannot be chemically broken down into something simpler. Now, we had discussed that like the ancient Greeks, all the way up to people in the 1800s, thought that the atom was the smallest particle in the universe. And it wasn't until the late 1890s that the three subatomic particles that we're going to discuss in this class were discovered. So protons are a subatomic particle. With a positive charge.
Good morning. Please excuse this interruption. Miles, Clay, please report to the main.
All right, sorry about that. So protons are a subatomic particle with a positive charge. And they're located in the nucleus. Neutrons are subatomic particles with a neutral charge. And they are also located in the nucleus of the atom. And electrons are a subatomic particle with a negative charge. And these are located in space outside of the nucleus. So I know that that's a lot of definitions and this looks kind of crowded, but a lot of these things you should be at least familiar with, that you've seen them in the past. And what a major focus of the rest of the course is going to be is looking at how do protons, neutrons, and electrons behave in atoms and different elements, and how do they kind of dictate how matter interacts with, or certain types of elements interact with others. Okay, now, what the atom looks like is a field of intense study. Even now, we're still learning more about how the atom is arranged. The very first model that incorporated these subatomic particles was called the plum pudding model. And this was put forth by J.J. Thomson in the 1890s. And so what he thought the atom might look like is a positive sphere with negative charges kind of dotted throughout it. So Thomson discovered electrons, or now what we now call electrons, which have a negative charge. Now, the plum pudding model is not correct, but it was a major step in the right direction in incorporating these subatomic particles into the model of the atom. So before this model, we thought that the atom was just like a dense sphere. This sort of incorporates what Thomson discovered, which were those negatively charged electrons that are really, 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 really small and kind of distributed throughout the atom. Now, about 15 years later, we talked about Ernest Rutherford and the gold foil experiment, and this led to the nuclear model of the atom. So Rutherford shot those alpha particles at gold atoms and saw that some of them were deflected. And he reasoned that they were deflected by what we now call the nucleus. So the nuclear model has a central nucleus that is small and dense. So we call this the nucleus. And the nucleus is positively charged because it has protons and neutrons. And then floating on the outside of the nucleus were tiny, tiny, tiny little electrons. In between the electrons and the nucleus is empty space. So if you remember when we did that simulation, most of these alpha particles were just flying right through the gold atoms. And so that's where Rutherford reasoned that most of the atom is probably empty space. But if those alpha particles did happen to encounter the positively charged nucleus, the positively charged alpha particles were deflected. And so, whereas Thomson discovered electrons, Rutherford discovered the nucleus. And so, because a few of those alpha particles were deflected, he built on or corrected the plum pudding model and created what we call the nuclear model. So this is in line with present thinking. So this is more correct than the plum pudding model. And we're going to build on this model as we progress through the course. Okay, so you should be able to draw these two models and analyze them. So if I asked you a question like, which subatomic particles are in the nucleus according to the nuclear model, you should be able to tell me it's the protons and neutrons. What charge does the nucleus have? Well, protons have a positive charge, neutrons are neutral, so the nucleus is positive. Okay. Let's keep going. So let's run through these questions really quickly. Key concepts and questions. These are questions that I could ask you in maybe a short answer form or in multiple choice. So, are atoms the smallest particles in the universe? Explain. Well, we just talked about subatomic particles. So if there are pieces that make up an atom, then atoms can't be the smallest thing. So the answer is no, there are protons, neutrons, and electrons, which are all small. Okay, what charge do protons, neutrons, and electrons have? We know protons are positive. P for proton, P for positive. Neutrons are neutral. You have that prefix. And electrons are negative.
Sorry for the interruption. Can Malia Collins please report to the office? Malia Collins, please report to the office.
Okay. Next, be able to describe the Rutherford gold foil experiment and how it led to the nuclear model of the atom. All you have to say is positive alpha particles were deflected by the positive nucleus that led to nucleus in the atomic model. Okay, now, number 4 says, be able to use the periodic table to determine the number of protons, neutrons, and electrons in a neutral atom for any element. You can sit here and Google these all day when you're studying. That is not what I'm asking you to do. Anyone can Google how many protons, neutrons, and electrons carbon has, but I want you to be able to use the periodic table to figure this out, okay? And the reason is you're going to learn later that the periodic table is this extremely useful tool, and Google is going to be much less helpful with this. Okay, so what we're going to do is we're going to look at a carbon atom. I'm going to try zooming in. Okay, so you get 2 pieces of information or there are two big pieces of information that you should be able to use. The 6 right here, this number in the upper left-hand corner, is the atomic number. And this number down here is the atomic mass. The atomic number tells us how many protons and how many electrons does a neutral atom of that element have. So carbon has 6 protons and 6 electrons. So we can go over here and write that right here. So how many protons? 6. How many electrons? 6. Okay. To find the number of neutrons, we need to do the atomic mass minus the atomic number. We always round the atomic mass to the nearest whole number. So if it's 12.0, we're going to round that to 12. So atomic mass minus atomic number is 12 minus 6, which is 6 neutrons. Okay. Next we have, they're asking about zinc. So I'm going to find zinc on here. And again, on a test, I'll be a little bit more deliberate about pointing out where it is, but zinc is right here. Atomic number is 30. Remember, the atomic number tells us how many protons and electrons a neutral atom from that element has. So zinc has 30 protons and 30 electrons. For neutrons, we're going to round the atomic mass to the nearest whole number, so 65. The reason we're going down is because if it's 0.3, that's closer to 0, or sorry, it's closer to 65 than 66. So 65, and then we're just going to subtract 30. So 65 minus 30 is 35. So again, anyone can Google how many protons, neutrons, and electrons an element has, or an atom from an element has. I want you to be able to use the periodic table because this is such a useful tool that knowing how to use it is way more important than being able to Google things. Okay, last thing. I want you to be able to do density calculations. There is a formula that we used, and I wrote it earlier. Density is mass divided by volume. There it is. We can write this in different ways. So if I multiply by volume on both sides, I get mass equals density times volume. And then if I divide by density on both sides, I get volume equals mass over density. So we're going to use those 3 versions of that equation to do some calculations. So here, I'm being told that a substance has a mass of 10.1. So I always like to fill this in. So mass is 10.1 grams. So I'm going to put that in for M. And a volume of 13.2. So V for volume. Calculate the density. So I don't know the density. So I'm always going to choose the equation where the missing variable, the missing letter, is on the left side of the equal sign. So I'm going to write D equals, and then I'm going to plug in 10.1 for M. And I'm going to plug in 13.2 for V. not seeing my calculator, so I'll just use my phone. So we're going to do 10.1 divided by 13.2, and we get 0.765. And the units are grams per milliliter. Let's use that same strategy for the next one. So here we have a substance that has a density, so we'll fill this in. D equals M equals V equals. So here, D for density, density is 1.13 grams per milliliter. What is the mass of 10 milliliters of that substance? So volume is measured in milliliters, so this is 10, and they're asking, well, what is the mass? So wherever we have our question mark, we want that to be on the left side of the equal sign, so we're going to use mass equals density times volume. So mass equals density, do 1.13, times volume, 10. And when you calculate that, you would get 11.3 grams. Okay, last one. Here, we're going to look for density, mass, and volume. It's telling us we have a density of 0.75. So I'll write that in for D. What is the volume? That means we don't know V. What is the volume of a 102 gram sample? So when you see 102 grams, if it's just grams alone, that's a mass. So here, our question mark is with the volume. So we're going to use the equation where V is on the left side. So V equals M over D. M is 102. D is 0.75. Get our calculator. (102) divided by 0.75 is 136. So our volume is 136 milliliters. Now on your test, I make the numbers simple enough that you will not need a calculator to do the calculations. So just keep that in mind. Okay? So those are all the things that I want you to be able to do for this upcoming quiz. That's it.